Okay, looks like things are cooperating now. I had multiple failures here. The streamer seemed to have crapped out there, and also YouTube preview was not working, so I'm just checking everything out. Okay, I think we're okay, so I'm going to go ahead and move forward, and if there's any problems, please mention in the chat window. Okay, big news here. We have a major earthquake in Oklahoma. I've got word here of a 5.3. This was about 20 minutes ago. This is going to be the strongest earthquake probably in about 3 or 4 years. So that's going to be in the news a little bit. Here in Texas, though, we've got a warm air advection pattern. So we've got southeasterly winds here. You can see high pressure out over the Mississippi River Valley, Ohio River Valley. So that's putting us under the southeasterly flow. It's ironic because I was trying to talk to you a couple weeks ago about Isotropic Lift, and that's the stream that failed. So I think we've got probably the isentropic curse here. But I'm going to try to get this covered here, and I'm going to check back and make sure everything's working. Okay. Isotropic Lift. Let's take a situation where we have southeasterly flow. I'm going to draw out the skew T kind of like this. Let's say we have a warm air advection pattern. So as we go up with height in this sounding, we notice that the potential temperature increases with height. Potential temperature lines slope up and to the left. See, we have 20 here. As we go higher, we have 30 and 40. So we start out with, say, medium potential temperature values, and they become warm with height. Okay, that's simple enough. Let's make the air mass a little bit colder. We'll draw the line like this. So now we start out with very cold potential temperatures near the ground. So we have 10 degrees here, and they increase to 20 and 30. So what I'm trying to show you here is the temperatures, they do fall with height, but potential temperatures actually increase with height. And that's very important when we are looking at isentropic lift. That's a source of lift we get during the cool season. Here's a good way to kind of visualize this. It's the analogy of a bed and covers. And I used this person here in bed to reflect the cold air mass. And the blankets that we see here, these represent isentropic layers. And you can see that they increase with height here. Now, in the cold air mass, we start out with a lower value, and they increase with height. So what's happening here is the isentropic surfaces are bumped higher over the cold air mass and lower over the warm air mass. And just to give you an example of that, I'm going to pull up a few isotropic charts for today from College DuPage. Yeah, here we go. This is the current isentropic chart. Let me set the right one up. Okay. Get this centered here. Okay, so you can see that we have the warm air advection pattern over Texas. There's a southerly flow just off the surface. And you'll notice these values right here. These represent the height of this particular isentropic surface, which is 300 Kelvin. It's labeled right down there in Kelvin. So this is basically the height you would have to ascend to reach the temperature layer for 300 Kelvin. In other words, if we go to the sounding, 300 Kelvin, that's going to be about 26 Celsius as far as temperature. There's 20, 30s over here, so that's going to be right about there. So this is the layer on the sounding you would have to go to reach that layer. Okay, well that's simple enough. So if we have a cold air mass it's obvious we're going to have to go up a lot higher to reach that layer, to reach that intersection there. And that's kind of what we see here on this isentropic chart. Let me set that back. We have to go higher up in the atmosphere to reach that isentropic layer. Now, the other reason that this is important is because air parcels tend to cling to the isentropic surface when there's no diabatic processes like warming, precipitation being released. Actually, that is happening right now, but anyway, just bear with me here. Let's say a cat is stuck within the blankets. This represents a parcel that tends to conserve its potential temperature. It wants to stay close to its potential temperature value. So if the wind tends to blow it this way, over the cold air mass, it's going to want to rise. If the wind happens to be blowing the cat the other way, we can see it's going to sink. In this situation, though, we have southerly winds, which is driving it over the cold air mass. So the cat rises, and that gives us rising motion. So that's what's happening here. So the isentropic chart is showing us that when we have wind blowing from lower heights to higher heights on an isotropic surface, we get a lot of lift. So this whole area here is a region of isentropic lift. This is basically overrunning. If we go up to a higher isentropic level, this is 305, 3010, we're going higher up. This is about 900 to 800 millibars, which is going to be about 5,000 feet. And up there, we've got a lot of isentropic lift. So that right there is an introduction to isentropic lift. Finally got through that, and I guess the stream is working, so we are free of the curse. All right, maybe we'll go into a little bit more detailed presentation about that in an upcoming webcast. But there's the isentropic lift right there. This is earlier today. You can see a lot of that stratocumulus and stratus mid-level clouds across Texas. And a few embedded showers and thunderstorms there. Okay, quick look at AWIPS. Let's see what it's showing for our current weather. Did I really lose AWIPS? I think it decided to... Yeah, here it goes. Yeah, for some reason it's got to redraw everything. Okay, no, actually, here we go. Our heights are working, so let's go with that. Okay, so this is the 500 millibar heights as seen on AWIPS. This is the NAM model. So this is normally the model that we're going to use in the 0 through 48-hour time frame. And it's showing a trough across the front range of the Rockies. And this upper level trough corresponds to cool air. It's actually cool air that's being dammed against the mountains here with a southeasterly flow. And we're getting a little bit of wave action rotating through the trough. Okay, so there's one wave, there's another wave, and ahead of these waves we're getting some upward vertical motion. So this particular wave right here, this is responsible for a lot of the showers we're seeing here on the radar. Radar not plotting on that one, but we've got radar right there on this other chart. And that one's still low too. Okay, so there we go. Large area of showers and a few showers up around the Wichita Falls area. So this is all associated with that wave in Central Texas right there. So what's the forecast over the next 48 hours? Let's check this out. Looks like the trough kind of deepens a little bit over Texas. That's kind of tied into that cold air mass across the state. And it looks like that kind of hold and anchors across Texas. So we're probably going to see continued dreary weather here over the next few days. Kind of a weak cold core developing right over Texas itself. And then we have this ridge building in across the west coast, so things look actually pretty good out in that part of the country for the next couple days. And let's just go ahead and go into the forecast here. So this is what we go through when we review the charts and look at the forecast. This is kind of an abbreviated version there, but here's Texas, Texas right there. You can see that warm air advection pattern. There's the isentropic lift right in this area. You can see the very high humidities in this area. So what happens to the front over the next few days here? Got one coming on the west coast right here. Looks like that front south of us kind of lifts very slowly northward as a warm front. It's hard to pin down exactly where that is, but it looks like continued overrunning over that frontal surface right in here. So things are going to stay pretty cloudy and wet here in this part of Texas. And then finally we get some high pressure building in from the northeast. Cold air advection on the east side of that. See how these thickness lines kind of bend south like that? This is the cold air mass. Kind of a reinforcing shot working down the backside of that high. And this is helping us get some height falls aloft. So all this stuff is tied together very strongly. So it looks like when we get the bulk of this high pressure shifting into Texas around Wednesday, we finally start drying out a little bit. And we get the warm air advection aloft turning more into cold air advection. Okay, then looks pretty stagnant over the next, let's see, a couple days towards the weekend. Northeast U.S., they get a reinforcing shot of cold air coming down through here. This is on Friday. So it looks like a very good cold air outbreak coming down south. Another front working into the Pacific Northwest right there. And look at that. Wow, that's very cold air here. 522 decameter thickness over New York and New England. There's the leading edge of that cold front. And then we're going to start looking out to the west. East Coast moderates, and here comes the next front into the Pacific Northwest. So things are getting active out there. And then, let's see, we're around Tuesday or Wednesday, the 16th, 17th. Now things get very active out in this area. And those of you who have been on this webcast for a while, you know that this is probably the cold bias of the GFS showing up. This normally sets in about 250 to 300 hours, but we're at 240. So this is actually concerning. This may be our next strong frontal system in the western U.S. the middle of next week. So we're going to have to pay close attention to that and look at that 1040 high over British Columbia with a very good push of cold air into the western and central U.S. there. So hopefully that happens. I would like to see a big change to the weather here. That would kick quite a bit of cold air southward there. And we're done. I guess we managed to salvage the beginning of this weathercast, and hopefully y'all learned a little bit of something there about isotropic lift, and we'll try to go over that again tomorrow because we're going to have this pattern continue, and we can probably kind of like hammer that down, and you guys can you guys will probably be a little bit more of an expert in that by the time we finish tomorrow. So I hope that worked out for you, and hope you all have a good evening, and I'll see you tomorrow. Thanks.